The next mechanic in the Parkour series will be a wall run climb move. If the player runs into a wall and jumps, if the wall is tall enough then the player will run and climb up it. If there is no space to land or the wall is too thin, the player will not run and climb it. The move works on walls that are not straight but not too steep. It will not work for angles that are facing downwards as it would be unrealistic. The system uses many traces to determine whether the wall is climbable. For this mechanic, I will use this animation called Wall Run from Mixamo. Make sure to download it without skin. I will use the Mixamo converter to convert it to a UE5 rig. For this one, press custom root motion and set frame, height, and rotation to 0 since we need root motion in the Z-axis as well and this fixes that. I will put a link to the software in the description. Next open Unreal Engine. I will make a new folder for Wall Run Climb. Import the animation. The root bone is moving but not in the Z-axis as expected. I am not sure what causes this error but I found a fix which is by deleting the output animation, repeating the step with setting frame, height, and rotation to 0, then re-importing the animation. Now the root bone is moving in the Z-axis too. Enable root motion on the animation. Next create an animation montage of it. First select the animation and change the end time to 1.6. This is adjusted since the end of the animation is in a crouched position but is not grounded so the player floats in the air so I decided to remove it. Now we will add the motion warp notifies. If you don't have this option, enable the motion warping plugin. The first notify should be from the start until the player starts to jump. Set the warp target name to starting pause. Uncheck warp rotation as we don't want to change that during the animation. Disable warp rotation for all notifies. The second notify should start from when the player jumps and ends when the foot hits the surface. The warp target name will be step 1. For this one and the next ones uncheck ignore Z-axis as well since we need to move the player up. The next notify starts when the player moves up and ends when the next foot is placed on the surface. Set the name to step 2. The next notify starts when the player moves up again and ends at the highest point of the jump. Set the name to peak. The final notify starts just after the previous one and ends when the player is grounded. Set the name to land. Now open the character blueprint. Make a new function called Wall Run Climb Trace. It will have 4 inputs. The first is a float called forward trace amount with a default value of 500. The second is a float called surface tracer gap with a default value of 25. Next is an integer called height tracer count with a default value of 4. The final one is a float called max angle with a default value of 10. The purpose of these will be explained when they are used in the code. Now we will add the outputs. There will be 5 vectors for each motion warp notify position. We don't need the return node here so just move it out of the way. Do not delete it like I did as that actually removed all the outputs so I had to re-add them after. Now add a sphere trace by channel. The start will be the actor location. For the end, add a vector. Get the actor forward vector and multiply it. For the value to multiply by, get the forward trace amount input. This controls how far away the player must be away from the wall to detect it. The radius will be 10. I will promote the draw debug type to a variable for easier debugging later. Drag out of return value and add a branch. Make a new Boolean variable called can_wall_run_climb. Set it to false if the branch is false. Next, break the sphere trace's hit result. Add a vector to the impact point and promote it to a local variable called start. Set this if the branch is true. For the value to add, multiply the actor forward vector by a new float variable called starting pause offset. Next, promote impact point to a local variable called initial hit location. We are using local variables here as these values only need to be read and accessed by this one function. Set the default value of starting pause offset to -150. These are all values that I trialed and errored with and worked the best with that animation. You can adjust these values if needed. This image shows how the forward trace works. Next, we will do a trace to find the landing surface. Add a for loop with break. We are doing multiple traces for this because the system should work on any object, so if there is an irregular shaped object with indents or bumps on the surface, then the system should account for that. Add a sphere trace by channel. Set the last index of the for loop to 15. For the start position, get the initial hit location local variable and add a vector to it. For the value, get the actor forward vector and multiply it by the surface trace or gap input. This variable determines how far apart each trace is. Add a pin to the multiply and set it to the for loop's index. Add two vectors to this for the start and end. For the start, set z to 500, and for the end, set z to 300. This makes it so the trace happens from above down to the wall so we can find the surface of it. Set the radius to 10. Next, add a branch and break the hit result. Make a rot from x of the normal. Split the struct pin and check if the pitch is nearly equal. Promote b to a local variable called compare angle. Drag out of return value and add an operator. The second condition is if compare angle is not equal to 0. Make this the branches condition. If false, set compare angle to the pitch. If true, add a sequence with then 0 being break of the for loop. In then 1, promote the hit results location to a local variable called found floor location. Then set can_wall_run_climb to true. This image shows how this trace works. Two consecutive normals must be identical for a surface to have been found. Next we will do a trace to determine if the detected wall is runnable by ensuring it is consistently straight enough throughout. Add a branch that checks if can wall run climb on completed of the for loop with break. If true, add a for loop with the last index being the height tracer count input. Next add a sphere trace channel in the loop body. This section might be a bit complicated, so I will try to explain it as best I can. For the start, get the actor location and add a vector to it. Split the pin, then get the found floor location local variable and split that pin as well. Subtract the z value of the actor's location from the found floors. This is to find the difference in height between the actor and the wall surface. Next, divide it by the height tracer count. This is to equally divide the height into the number of traces we want. Next, multiply it by the loop index. This is since every trace needs to be offset by the interval amount, so multiplying it by the index which increments each time achieves this. Finally add a float with a select node. The condition will be if the index is either 1 or 2. This is since those two indexes will be used to find the footstep locations. If you think the player jumps too high for the first step, you can remove this add node. If A, then set it to 20. Set this as the z value to add. Add another vector for the end. Get the actor forward vector and multiply it by forward trace amount. Set the radius to 20. This radius is higher since we need to ensure that hits are detected, so if the radius is too small it might miss. Add a branch using the return value. Make a new float array variable called compare float angles. This will store all the normals of the multiple traces we did. If true, add a value to it. Break the hit result and make a rot from x of the impact normal. Split the pin and add the pitch value. Next drag out of impact point and add a reroute node. Add reroute nodes to the for loops index as well so the code is cleaner. Add a switch on int. This allows us to run different code based on the value of the index. Add pins all the way up to 4 and remove the default value. If you change the value of the height tracer count in the function input, then you may have to adjust the switch on depending on the value of it. Set the start index to 2. Add a vector to the impact point which will be the actor forward vector multiplied by a float called step 1 pos offset. Promote this to a local variable called step 1 and set it if the int is 2. Do the same for step 2, making a new offset variable and setting it if the int is 3. You can remove the last switch on index as we only need 4. I will now comment this trace. This image shows how the height tracer works. Next we will do a trace to detect the peak point. Add a capsule trace if the switch on int is 5. For the start, add a vector to this impact point. Set the z value to the capsule half height. This is since we want to check if there are any obstacles at the peak point the same radius and height as the character's capsule component. Add another pin to the add vector and multiply the actor forward vector by a new float variable called peak pos offset for it. Set this as the start and end. Get the capsule radius and half height for the trace's radius and height. Add a branch using the trace's return value. Subtract the half height from the vector and promote this to a local variable called peak if false. This is since the position to move to should not be offset as it moves based on the root position while the trace needs to be offset since it isn't. This image shows how the peak trace works. Now we will set the pos offset default values. Set step 1 offset to -150 and step 2 and peak offset will both be -50. Again, you can adjust these values later if you need to. Also, make sure to set can wall run climb to false if the capsule trace is true. Now get the compare float angles and add a for each loop with break. Call this on the for loop completed. This will be used to check if the wall is runnable by checking all the normals. Add a branch on loop body that checks if the absolute value of the array element is greater than a value. Absolute means the positive value, so it will return just the magnitude, ignoring the sign. Check if it is greater than the max angle. If true, add a sequence with then 0 being break of the for loop. In then 1, set can wall run climb to false. I will now put the variables into categories since it is not that readable now. On the for each loop completed, add a branch that checks if can wall run climb. If true, add a line trace by channel. This will be to check if there are any obstacles in the path. For the start, add the actor forward vector multiplied by -20 to the initial hit location. The end will be the peak local variable. Drag out of the return value and add a branch, setting can wall run climb to false if true. This is a very simple trace which works as shown. If the branch was false, add a capsule trace by channel. These will be 2 final traces for the land position. For the start, get the found floor location and add a vector to it. The Z will be the capsule's half height. Add another pin and set Z to 30 for an extra offset. Set this as the start and end. Next, set the radius and half height to that of the capsule components. Add a branch using the return value and set can wall run climb to false if true. Subtract a vector from the add with Z being the capsule's half height. Then add the actor forward vector multiplied by a new float variable called landPos offset to it. Set the default value of this to 10. If the branch is true, promote this to a local variable called land. This image shows how this trace works. Next, add a capsule trace by channel. This is the final trace to check if the player can actually land at that spot by checking if there is a floor. For the start and end, get the land local variable and add the actor forward vector multiplied by 20 to it. Add another pin and set Z to -20 to offset it to where there should be a floor. Set only the radius to the capsule components. The half height will be 20. Add a branch using the return value. If false, set can wall run climb to false. This image shows how the trace works. If the branch is true, add a branch. Get the distance between the start and land local variables. Check if this is less than a new float variable called wall run climb max distance. Set the default value to something like 450. This is a final check to ensure that the climb to position is not too far away. If false, set can wall run climb to false. If true, add the return node. This is where I had to re-add all the outputs since I deleted the return node earlier. Set each output to the corresponding local variable. Now make a macro called wall run climb. It will need a vector input for each motion warp target position. Get motion warping and add or update warp target, splitting the warp target pin. Drag the exec pin into the input to make that an input too. Set the warp target name to starting pos. Make sure it is titled exactly as you did in the motion warp notify, including case sensitivity. You can copy and paste them directly from the animation montage if you want. Since this part is repetitive, I will speed it up. Next, set the movement mode to flying. This is since otherwise the player will not be able to move up while the montage is playing. Then stop movement immediately to 100%, ensure there is no extra movement. Then get the mesh and play montage, setting the montage to the wall run 1. On blend out, set the movement mode to falling. We are setting it to falling instead of walking since the land position is not fully grounded, so the player needs to fall a bit before they land. This also made the system look more realistic. I will now comment the macro. Now we will call the function and macro in the jump input. Replace the jump node on started with a branch. The condition will be an operator with 3 conditions. For the first condition, we will check if the player's speed is above a certain value. We can do this by getting the vector length of the character movement's velocity and checking if it is greater than. I will use a value of 400 to check against. The next condition will be is falling not, as the player should not be able to perform the wall run climb if falling. The final condition will be checking if the wall run climb is not already playing by getting montage is playing from the mesh's anim instance. If true, call the wall run climb trace function. Add a branch that checks if can wall run climb. If true, add the wall run climb macro and connect the outputs of the function to the inputs of the macro. If both branches are false, connect it to the jump node. I will enable all debugs to see the traces while testing. I will quickly make a test map to showcase all the features. traces are working but the wall run climb is not. To fix this, go to the switch on int in the wall run climb trace function. Change the start index back to 1. Make sure the pins with code running are 1, 2, and 4. Now it is working. If the animation is too slow or fast, you can adjust it in the montage by changing the play rate. For this animation, a play rate of 0.9 looked good for me. This bonus section shows how to integrate the system with the rest of the Parkour series if you followed along for those. First, make this wall run and wall slide jump to a macro to make space. I will convert the wall run climb code to a graph. Drag the branch pin to the input. Replace the jump node to an output. Make sure both go to the same output pin. If false, then call the onJump event. Before the reset XY rotation event is called in the onJump event, add a branch that first checks if sliding. Now the system is complete. The player cannot wall run climb if there is not a landable floor. Values can be easily adjusted to make sure the feet are placed on the wall. That is all for this video. You can purchase this project using the link in the description if you want. If you enjoyed, like and subscribe for more content. Thanks for watching.